Okay, now let us try this example using the method of separation of variables to solve the initial boundary value problems. Given the partial differential equation is this, and the length of x is start from 0 up to pi, and t is greater than 0. And they gave you three conditions. The first one is when uxt, when x is equals to 0, the value of u is equals to 0. The second one is when x is equals to pi, the value of u is equals to 0. And the last one is when t is equals to 0, the value of u is equals to 2. So we can identify this where the condition 1 and 2 are the boundary condition because this is the condition at the boundary. And then this is the initial condition because initial condition is the condition when t is equals to 0 or when at starting point, at starting time. Okay, now we have all these conditions. First, what we need to do is list down all the terms that needed in order to solve this PDE. So we list down, okay, what we need is we need to use the method of separation of variables. Okay, the previous slide I show you where the solution of the PDE we already obtained in terms of this form. Where in order to get this is we have to use the method of separation of variables from del u over del t k squared del squared u over del x squared. So we don't need to do the method of separation for this PDE. We just have to substitute into this solution. Okay, now we have the PDE which is del u over del t equals to 4 del square u del x square, where 4 is the value of k square. Okay, the next thing that you need to have is the length of the x, where the length is start from 0 up to pi, so the length of x is equals to pi. And the last one is the function of x, where fx is the value of the initial condition, where fx is equals to 2. Okay, now we have all this, then we can substitute into the coefficient of Fourier sine coefficient, where Tn is equals to 2 over L, where L is equals to pi, multiply with the integration of this from 0 up to L, which is pi, and fx is equals to 2 sine n pi x over L, which is pi dx. So now we can proceed by taking the integration. So we take out 2, so this will become 4 over pi, 0 up to pi sine. This one can be cancelled out, so we get sine nx dx. So integrate sine nx, we get negative cos nx, where the limit is from 0 up to pi. Then substitute this, we get 4 over pi negative cos n pi minus negative will be positive cos 0, and this will become cos 0 is equals to 1, or we can rewrite this as equals to 4 over pi negative 1 to the power of n as 1. Or we can simplify this. We know that when n is equals to 1, we get this negative 1, 1 plus 1, which will be 4. 1 plus 1 will be 2. So So 2 times with 4 we get 8 over pi when n is equals to 1, 3, 5 and all odd numbers. And when n is equals to 2 or even numbers, we will get here is 1. So negative 1 plus 1 you get 0 for n equals to 2, 4, 3, 1. Now we can proceed by substitute Tn into this equation. Okay, now we can solve uxt, where this is equals to the summation of Tn sine n pi x over L, which is pi e to the power of negative n square pi square k square is equals to 4 times with t over L square, where L square will be equals to pi square. So we can cancel this out and we have Tn sine nx e to the power of negative 4 n square t. Now we can expand this, where this will be u equals to t1 sine x e to the power of 4 times 1 square t plus t2 sine 2x e to the power of negative 4 2 square t plus t3 sine 3x e to the power of negative 4. And when n is equals to 4, we get like this. Okay, so now I'll just stop until n equals to 4. Then now we substitute t1 with this function. Okay, where we have u as t1, when n is equals to 1, we have t1 will be 8 over pi sine x e to the power of negative 4 1 square t, and d2 is equals to 0. So this will be equals to 0. And for every even number, when n even number, you will get d for d is equals to 0. So this, the next one will be d3, where d3 is equals to 8 over pi sine 3x e to the power of negative 4 3 square t plus and so on. And this we can simplify it as we can, this 8 over pi is a constant that we can factorize. So this will be 8 over pi, and the next one is the summation of start from 1 up to infinity. So the series start is only for the even number, this one and this one. So this can be written as sine 2n minus 1x e to the power of negative 4, and this is also increasing with odd number or increasing with 2. We can write this as 2n minus 1 square times with t. So this is the solution of the PDE del u over del t equals to 4 del square u over del x square. So this is the solution.